Sanjay, could you just read out what that square root of 1 plus x is? Again, that series which we copied down. Just quickly, 1 plus. So not this one. I want the one which we had before. This one here. So when we simplified it, so you get 1 plus.
1 by 2x.
Yeah.
Plus minus.
Yeah.
Minus 1 by 8x squared.
Yeah.
Plus 3 by 48x cubed.
Good. Okay. Fine. Good. Okay, fine. So this is my square root of 1 plus x. Now you've just seen that the square root of 1.5 is easy enough to work out. Okay, it's easy enough to work out. What now if I replaced x with a different number? What if I replaced x with 3? Okay, so in other words, I tried to work out the square root of 1 plus 3 or the square root of 4. Now clearly you know this should be equal to 2. So let's see if this sequence, or this series I should say, gives me 2 in return. So let's check it. So let's stick x equals 3 in here. So we're going to go 1 plus a half lots of 3 minus an 1/8 lots of 3 squared. Happy? Plus 3/48 lots of 3 cubed, etc., etc., etc. Doesn't look like 2, but let's give it a go. Let's just make sure. Okay, so you get 1. This is 3 over 2, or 1.5 if you prefer. This is minus 9/8. This is plus, that's 27 times 3, so that's 81/48, etc., etc., etc. That's not looking like 2, is it? Because if you try it out, this is going to be 1 plus, well actually no, could you type that in your calculator to see what we get? So could you just type that series there, 1 plus 3 over 2 minus 9 over 8 plus 81/48. Can you type that in your calculator, see what we get? 0.0625, okay. So okay, we get 2.0625. So when we try x equals 3 in this, we get 2.0625. Now clearly that's not right, like we want that to be equal to 2, okay. So this worked. When we tried sticking x equals 1/2 into our series, this worked. This came out really nice. Well, not nice, but it worked, okay. So we were able to work out what the square root of 1.5 was. But when we do this, when we try x equals 3 in here, we get a number that isn't 2. Okay? And in fact, we're just going to get a number which is further away from 2 every term that we add. Okay? So there's clearly something going on here. There's clearly a condition for when this works and when this doesn't work. Does anybody know? So does anybody know, like this, so square root of 1 plus x, or 1 plus x to the power of a half, is equal to this series. Okay? That's what would happen if we tried to expand it out. But the condition is, this would only be true if we stick certain values of x in. Does anybody know the condition on the values of x that we stick in? So the condition is, for this thing, that we're only allowed to put values of x between -1 and 1 in. Okay, so you've got to be between -1 and 1 in order for this series to hold. Okay, so in order for this series to hold true, we're only allowed to put values of x in between -1 and 1. Okay, so the condition is, it is only valid for values of x between -1 and 1. Or if you prefer, if you want to just say, just use the positive one, so I could use the absolute values symbol, would you be happy that's got to be less than 1? Okay, so of course if I stick a negative number in here, it comes out as positive by using the absolute values. Is that okay? Yeah. Sorry? For this thing? Yeah. So for this thing here, it would just be this. Okay, so you're only allowed to put in values between -1 and 1. So sticking in x equals 1/2 or x equals 0.5 is totally fine because that is between -1 and 1. But when we try to do something like this, x equals 3 in, because 3 isn't between -1 and 1, it didn't work. Okay, it didn't work. In fact, you notice these inequality symbols. It's not even including -1 and 1. So in other words, if I went and tried to stick 2 in here, sorry, 1 in here, okay, so 1 or -1 in here, so I tried to work out 1 plus 1 is square root of 2, okay, this also wouldn't hold true. Is that clear? Yeah, so it's only valid if we stick in values between -1 and 1, okay, but not including -1 or 1. So in general, when we had our 1 plus r to the power of n, when we expanded this out, okay, and we got our series, so when k is equal to 0, and it was like n times n minus 1 times by all the way up to n minus k minus 1, okay, divided by k factorial, and then we had r to the power of k, okay, so this is my general expansion in terms of sigma notation, okay. This thing here would only hold true if r, because I'm now using r, if r is between -1 and 1. So I'm just going to write it like that. The modulus of r has got to be less than 1. Okay? So basically, if you're going to expand this thing out, and if n, I should say, if n is a negative number or a fraction, okay, then this will only hold true if r is less than 1. Okay? If this is an integer, it's fine. It's totally fine. Okay? But this thing here will only hold providing that r, the modulus of r, is less than 1. So it's got to lie between -1 and 1 if n is a fraction or if it's negative. Okay, so if n is a fraction, the power is a fraction or it's negative, in other words, it's going to result in an infinite series, then this thing will only hold providing that the thing we stick in there is between -1 and 1.